Class 11 Limits and Derivatives exercise 13.2. In this exercise we completed 5 questions. Now we will find the derivative of the sixth function. So question number 6, x to the power n plus a into x to the power n minus 1 plus a square x to the power n minus 2 plus a to the power n minus 1 x plus a to the power n. So this is a polynomial function they have given to us. So they have given a function to us. We have to find the derivative of this function. We have to find f dash of x, and which we can also represent as d by dx of f of x. So function is given to us, f of x. We have to find derivative of the function, which is also represented as f dash of x. Now let us label the function. Let f of x is equal to x to the power n plus 2x to the power n minus 1 plus a square x to the power n minus 2 plus a to the power n minus 1 x plus a to the power n. So here a is some constant. So now we have to find f dash of x. To find f dash of x, we have to differentiate. It's a verb. We will differentiate both sides with respect to x. We have, so if we differentiate, we will write d by dx of f of x is equal to d by dx of the function, that is x power n plus a into x power n minus 1 plus a square x to the power n minus 2 plus a to the power n minus 1 x plus a to the power n. Now we know that d by dx of f of x, d by dx of f of x is the same as f dash of x. So here we have d by dx of f of x. So we can write this as f dash of x is equal to, now we have derivative of the polynomial function. That is, we have sum of many terms here. So when you have sum of terms from the algebra of derivatives of u plus v is equal to du by dx plus dv by dx. So when you have two terms, sum of two terms, you write the two derivatives, and it applies even when you have more than two derivatives. So we will write d by dx of x power n plus d by dx of a into x to the power n minus 1 plus d by dx of a square x to the power n minus 2 plus d by dx of a to the power n minus 1 x plus d by dx of a to the power n. Now this implies f dash of x is equal to, now we have the formula d by dx of x power n. From the power rule we have, when you have x power n, you write n into x to the power n minus 1 plus, so d by dx of a into x n minus 1. So here a is a constant and x to the power n minus 1 is a function. So we will bring a outside and we will write d by dx of x to the power n minus 1 plus the same thing here, a square. Now we will differentiate the x to the power n minus 2 plus a to the power n minus 1, then d by dx of x plus, now the d by dx of a to the power n is nothing but derivative of a constant, right? So derivative of constant is 0. So derivative of constant will be 0. So we will write here plus 0. Now this implies f dash of x is equal to n into x to the power n minus 1 plus a times d by dx of x power n minus 1. I will solve here. D by dx of x to the power n minus 1. Now it is the same. Like in the place of n we have n minus 1. Right? So we will write in the place of n minus 1, x to the power n minus 1. Again we have minus 1. So this will be n minus 1 x to the power of n minus 2. So we will get n minus 1 into x to the power n minus 2 plus a square d by dx of x to the power n minus 2. So we will have n minus 2 x to the power n minus 2 minus 1. So n minus 2 x to the power n minus 3. So we will write here n minus 2 x to the power n minus 3 plus a to the power n minus 1 derivative of x. So you always remember this, derivative of x is 1, but we will solve here also. This is in the place of n we have 1. So 1 into x to the power 1 minus 1. So 1 into x to the power 0, which is 1. So we will get 1 here into 1 plus, and constant is 0. So therefore the derivative of the function, that is derivative of this polynomial function, is equal to n into x to the power n minus 1 plus a into n minus 1 x to the power n minus 2 plus a square into n minus 2 into x to the power n minus 3 plus a to the power n minus 1. So this is the required derivative of the polynomial function. Hence we completed the sixth one.